G'day guys, back with the Outer Circle, and in today's episode we're going to be doing a review on the Creality CR-10 SE. This review is going to be a little bit different to the typical review. To get it out of the way up front, I was sent a review copy of this 3D printer, which I've been using for 2.5-3 months now. And I had recorded two different versions of this review, but I wasn't happy with them, so I sort of put them to the side and said I'll come back and visit them later. And, well, today is later, and what I've decided to do is talk about what's wrong with the printer first, because it's getting a glowing recommendation, and not because it was sent to me as a review copy. When it comes to review copies, you have the option with companies of signing up to things like affiliate programs. So I can recommend the printer, put a link in the comments. If you guys click on the link and buy the printer, I get a commission. I have not elected to go into that because I believe there is potential there that I could have an inherent bias if I give something a positive review and I'm getting paid as a part of you guys purchasing something based on my recommendation. So know that I don't get any money out of this, although I did get the 3D printer for means of a review. So in saying that, and in the fact that yes, it is getting a glowing recommendation, why am I talking about what's wrong with it? Well, this printer is a huge step up from what's come in the past, and there's just a couple of things that I would like to see improved or modified that would greatly change the user experience. I'm going to go from least important to most important here. And the unit that I'm going to pick is a competitor unit, and that is the Sidewinder X3 Pro, which is a significantly cheaper printer. But it has a couple of features that I really approve of. The first of them is the fact that it has a little wiper at the back of the plate. Now that little wiper is designed for your nozzle. When you start a 3D print, it's programmed to go over and wipe the end of the nozzle on that particular piece of material, and this cleans the nozzle so you don't have a big chunk of old plastic on the end of the nozzle, which could cause an issue in the base layer of the print. On the Creality system, you have to manually heat up the nozzle and clean it off yourself. That's not anywhere near as good as the artillery system, and it's one of those small improvements they could make. The second thing is that the artillery system here, well, the cable management. You can see that the cables are these lovely ribbon strips built into the X-stepper motor, and the strip folds out of the way as the machine moves up and down. It is not a cable hanging off to the side of the machine. Although the cable management is very good on the Creality machine compared to that ribbon system, I think they have a ways to go. And we can see that they're making improvements if we look at machines like this, the Creality CR-10, how it has CNC conduit cable, which runs over the back of it and runs horizontally across the machine. That bit of CNC cable is holding all of those cables nicely, because remember, the more copper cable moves, the more it hardens. Copper is a material that work hardens, and over time it becomes more brittle. And that's why things like copper water pipes like to burst in walls, because eventually the minor vibration of the water traveling through the pipes causes the copper to get harder and harder and harder until it cracks, or it can corrode. But in the case of a 3D printer, we don't want a fracture to occur because of the constant bending action of the cables. And we don't want to snag the cables on anything either. And I think this system they've got on the M4 is probably the route I want to see them going down with all future printers. Now that's two issues, but what is the third issue? Well, the third issue stems from an improvement. And that improvement is they've moved to Clipper firmware. Now this means this machine can go very fast. 600mm a second max printing speed. I have managed to get it to go a little higher than that. Don't recommend it. But it is not a practical printing speed. Now, this is because the machine has not had its rigidity increased in proportion to this. Now, what do I mean here? Well, let's think about it. Every single part on this machine has inertia. So think to Newton's laws. For every action, there is an equal and opposite reaction. And objects in motion, okay? We need to somehow stop them going in one direction, then we need to apply an equal force going the other way, essentially. This causes us some issues when it comes to high-speed 3D printing, because if you want the bed and the object, which could have a kilo of filament weight on it, if you want that bed to rapidly move from one direction to the other, it has to take all of that motion, stop it, and then start moving it back in the other direction. That is an incredible amount of torque applied to very, very small motors and moving parts, and it's being transmitted through a steel reinforced rubber belt. Now, that toothed rubber belt is going to have small, minuscule amounts of stretch in it. Okay, and what it means here is we have energy loss, and we are also having a bit of a spring factor going on as it stretches and then contracts back to its length as it starts to take up the slack moving in the new direction. This induces small amounts of error. And of course, when we have the hot end, so the large device with the fan that sits in the middle of the printer, the hot end and the extruder is quite compact on the CR-10 SE. It's a big step up from the Ender 3 S1s, which I'll talk about in a moment. But with this particular hot end, you have the mass that is moving from left to right, and it's shaking around on top of the Z-axis supports. So these big aluminium brackets that run up each side, those are being shaken constantly by the direction changes going horizontally and the direction changes going in the Y-axis as the bed moves back and forth. All of these things in conjunction with one another cause quality issues. Now, this is not a problem unique to Creality by any stretch of the imagination, and it is not to the detriment of this printer in particular. But you cannot have these printers going to such high speeds without reinforcing them somehow. I think something like their K1 series has similar sort of things going on, and really the solution here is probably to look at something like this. This is the Ender 5 S1. Now, the Ender 5 basically has 4 vertical points here. So straight away, that's a huge improvement. But also the moving axis, the X and the Y, are at the very top of the printer, and they're moving in unison with one another. The Y is moving the long bar back and forth, and the X is moving the extruder and print head from side to side. That means we don't have mass moving at both the bottom and the top in opposite directions on the printer. So it reduces the vibration, the shake massively on the printer because of this. So that is a much better way of doing things if you're going to retain that. I think the basic shape and layout, which goes all the way back to the original Ender 3, is great. This simple shape of having the 2 vertical supports, which the X-axis runs on, and the Z-axis, and having the Y on the bottom is a proven concept, a proven design, and it works beautifully. Whereas the Ender 5s, which I have one of the original Ender 5 models, they've come a long way since. This design is fantastic for rigidity, but of course there are more complexities in the build, more parts involved, there are other trade-offs along the way. So something to think of. You get a much bigger machine physically for a same size print volume, for example. So again, trade-offs for everything. But rigidity is the killer. 600 millimeters a second is not realistic. 350 to 400 millimeters a second, that is the realistic print speed on the CR-10 SE. So that's my biggest qualms out of the way. And there's one minor thing. Now, this isn't an issue. This is just a miscommunication. That is this double filament you see on top. This does not print from 2 filaments. One of these is just simply storage. You're just holding a spare piece of filament up the top, and I think that would confuse and annoy some people. If they thought this printer could dual extrude, they might purchase it, which would be the incorrect assumption. That's not true. Now let's talk about the machine and what it got right. So if I was to plot a chart and it was going to have improvements in Creality's designs and in 3D printers in general in the hobbyist consumer market, and on the left-hand side, we had something like the original Ender 3. The quality improvements that went from the Ender 3 to something like the S1. I have a couple of these machines, actually, that I bought because I liked them that much. To go from those to this is less of a step over about 3, 4, 5 years now. It's less of a step up from the original Ender 3 to the S1 than it is in 1 year from the S1 to the CR-10 SE. Because really, this is an improved Ender 3 S1 in every aspect. And I would be recommending this as I know how to 3D print. and I want to go to the next step, this is a machine to do it with. This is that middle ground in 3D printing where you really want to 3D print, you want to make a lot of stuff, and you want to do it at a pretty good speed. This is the printer to do it, and it will do it phenomenally. Of one of those weird little quirks of 3D printing that you used to have to work out for yourself, like, I've just assembled a 3D printer, I'm going to run it for the first time, I wonder if it's going to, bang, if it's going to blow up. This doesn't have the issue, because when you turn this printer on for the first time, it will actually do a self-diagnostic, and it will run all of the components and check them that they're all functioning correctly and tell you if they're not. Fantastic feature and a long time coming. Another thing with pre-printers was, for years you bought one out of the box and you had to sit there and wind dials and adjust all of that, and then you had to go through this leveling process. This printer doesn't go through that leveling process. It has an auto level. Now, normally these auto levels in the past were a case of, okay, it runs an auto level, it maps out the print bed, but you still have to do things like adjust the Z-axis. The Ender 3S1, which I think of very highly, this went through it. Even the CR-10 Smart went through this system. Not the CR-10 SE. This thing did an auto level and then self-worked out what its Z offset should be. Fantastic. So the quality of life improvements here mean that out of the box, you have a 3D printer where you can almost turn your brain off. You are not having to go through and tighten all these additional screws and check all these dials. All of it has been done correctly for you out of the factory. Fantastic, awesome, great. Where has this been? We also have a much improved user interface where it will not only show you the files that you've got on your hard drive, as in the physical hard drive that you take in and out of your PC and slice files onto. It will save files onto it. It will show you files you printed in the past, what your settings were for them, how quickly you perform those prints, what time frame they took over. It will show you all of those settings in here. It will give you a graphical display on there. All of the information is held on that little touchscreen if you so choose to look at it. And it will show you a 3D representation of the file you want to print, how it's going to look as you print it. And as you print, it changes the color of it from a blue to a yellow as the print takes place to show you the progress of the print as it goes along. Fantastic. So all of that is great. Then they've stepped up their game with other components. So if we move down through here, we have linear rails. Now, linear rails, for those who don't know, are a high accuracy bearing surface, very low friction, fantastic application. And many people used to go who were really into their 3D printers, especially the big 3D printing channels all over YouTube. They would come along and they would retroactively upgrade old printers to linear rails. They are very, very precise. They are putting them into this printer stock standard. So the accuracy, again, this is one of those things you're paying for over competition like Artillery, who I think make great printers. You are getting a product which is far better because these run with little rubber wheels on aluminium extrusions. Nowhere near as accurate as something like this with linear rails. So if you dial down the speed from that ridiculous 600 millimeters a second, you can take advantage of that and you will get incredibly accurate parts out of this 3D printer. But be advised, these are not going to be tabletop miniatures like a resin print. These won't look like Games Workshop parts off the shelf. But what they will look like is very, very good parts off the shelf. They will look like resin parts from 7-8 years ago when the technology was very, very crude in the hands of the first resin printer hobby enthusiasts. So, big upgrade. Another massive change is the extruder. It's basically a refined version of what was on the Ender 3S1. Now it has a nice looking plastic shroud over the top, whereas the Ender 3S1 had this sort of just sheet metal stamped and laser cut shape over the front of it with sort of an exposed fan that it did the job quite well, but it is kind of ugly looking and it looks tacky, okay? It looks tacky comparatively. It looks cheap. The CR-10 SE doesn't have that issue. It actually has a hard plastic extruder cover and it looks very professional because of it and does have very good airflow distribution. But the big improvement in here is the nozzle, the actual hot end and nozzle. It's ceramic. Ceramic, what an improvement. So ceramic, for those who aren't aware, gives you incredibly even heat distribution. Whereas in the old hot ends, it relied on basically an aluminium block. So instead of having this even heat distribution into your alloy bimetal hot end, what you had was an aluminium block that you had to heat up, and you had to trust that the aluminium block was able to take the heat and then spread it evenly to your nozzle. And it didn't always do that. The ceramic heater, on the other hand, is incredibly consistent when it comes to temperature and quality. So, great upgrade. It also has this dual extruder drive, which dual extruders are always better. That's what I've always found. Dual extrusion has a lot more gripping power. So when it comes to pulling the filament through, it runs well. And I've run two Ender 3 S1s and a CR-10 Smart Pro, who all have the older style of this dual extruder. Internally the same, externally looks a bit different. But I've run them for well over a year, almost straight, like 24 hours a day for nearly a year. I have not had to replace any parts in this system, and they have never, ever failed me with extrusion. Never had an issue running PLA and PLA Plus through these machines. And now I say that because some plastics, like flexible filaments, can have issues, but again, that's getting outside the scope of what we're looking at, and not something that I've personally experienced with these machines. Then it comes to the types of materials. Now, the types of materials in here. Hyper PLA, it speaks for itself. It's just a proprietary PLA blend, so polylactic acid with different additives put in there to change the performance of it. Whereas your PETG, for those who don't know, PETG is polyethylene terephthalate glycol, and it's basically the same plastic that your drink bottles are made out of. Your plastic see-through drink bottles, right? Water bottles. CF, that is your carbon fiber. So it has these small particles of carbon fiber embedded into the PLA. The material is very, very strong, but it is incredibly abrasive, and it's a great way to tear the insides out of your machine. Although it can physically run it, I don't recommend that people go to it. PETG is a much stronger material, and it won't eat up your machine the same way, but the fumes are not crash hot. Then you've got something like HPASA. Well, ASA is acrylonitrile styrene acrylate. Sorry, I've got to remember all these plastics off the top of my head. So that's another good material. Similar performance to PLA, a little bit stronger, like ABS, abutylstyrene is, but has the downside of fumes. I'm not a big fan of the fumes of those. So you can run in this machine, but then you want to run it in a more ventilated area or have some sort of fume extraction. I recommend putting something like a grow tent or a cover over the top of the printer, and then making sure that you vent that to somewhere externally. Then you got TPU. Now TPU is a type of flexible filament. That would be thermoplastic polyurethane off the top of my head. And it's flexible. It squashes. It's very rubbery. Okay, and then PA, that's basically nylon. So all of these are great plastics. So if you have access to this printer, you can print in a variety of different materials. Now, what do I recommend printing in this? Well, it's pretty simple. I recommend printing terrain for wargaming. And so I did a ton of printing of terrain for wargaming. Many of my own designs, but also other designers. We have Sacred Mundus in here, for example, or Grimdark Terrain have also contributed files, which I've then gone along to print. Fantastic machine, and the speed is unreal. I'm printing 3 times faster than my existing machines for no really noticeable drop in quality. The only time I had a noticeable drop in quality was when I tried to make it print over 400 millimeters a second, and I started running into those rigidity issues that I was talking about. So those are things that you have to keep in the back of your mind. So overall, the printer gets a huge thumbs up from me. Now, before I finish off with this review and finish talking about what has been a fantastic printer, and I highly recommend getting this as actually a first printer, this is a fantastic printer, although it's expensive for a first printer. you're looking at around 700 Australian dollars off the top of my head. You're probably looking at around 300-400 American dollars for this sort of printer. But this is the sort of printer that you will get years and years of use out of. Proven technology, twin Z-axis motors, all that kind of thing. Great, fantastic. Like I said, the UI is much improved and the company is doing a lot to innovate. And I want to talk about this before I wound up this review, but my interactions with Creality of late, I've been invited along to events by them. Obviously, I've been supplied these review copies, but unlike other companies that I've dealt with, they've been willing to sit down with me and say, what can we improve on our machines? Like, tell us what you think these machines are lacking. And so I can say things like your cable management. I can say things like the type of extruders you might have, anything like that. And they will take notes because they're going away and they're trying to actually improve the product consistently. Now, different users may get different mileage, but for me personally, that does go a long way towards telling me that as a customer, they are going to try and improve the experience of these machines consistently. And that means that these machines are going to be supported long term and that the parts are going to be there long term. And again, if you're going to invest in a system that costs this much money, you need to have that foundation and feel assured that what you're getting is worth it. Now, if you do decide to look into these machines, I'll be putting links into the description below the video for you to check out. And if you do buy from them, if you buy from Creality through those links or anything like that, feel free to tag them or drop them a line. Just say that, you saw my review and that's the reason you bought it. If that's true, I would appreciate that, just so they understand that we are getting the message out there about these products. But don't feel any pressure to buy it, guys. Like, buy what you're comfortable with. And if this is not the right system for you, the right machine for you, then don't buy it. It's that simple, okay? But they're quick, they're easy to set up. You would have seen throughout the video assembly footage, it's like 8 screws to put one of these things together now. It used to take you hours. You can do one in about 10 minutes. It's just fantastic how far this technology's gone, and I really can't wait to see where we're at in 10 years' time. Anyway, that's it for me. I'm Mac with the Outer Circle. Thank you all for watching this episode, and I'll see you on the next video.